Good. So we have a few minutes left until we have a short break, and after the break we will go into the details. But let's use this first few minutes of the first lesson after the election to the Schulsprecher to quickly recap what we did last time. Quick question, okay? Can you remember what we did last time? A student in a lower class comes to you and tells you, I've heard the word delegate. I don't know what it is. What is a delegate? What would you say? It's not an exam. Wrong answers are perfectly fine. Yeah? It's kind of a pointer to a function. Yes. What else? It's a special kind of pointer. Yeah?
It's an interface for a function.
Yeah, I like that. It's an interface. It's a type definition for a function. So we can say it's a typed pointer or typed reference to a function. It's not just a pointer to a function where we don't know which parameter this function gets and what this function returns, but it's a typed pointer. A delegate knows what the input parameters are and what the return value is. That's the important thing. It's a typed reference. Why is it called delegate? Why didn't they call it function pointer? What does delegate mean? It's a strange word. Do we have a similar word in German, or do we understand the word German, the word delegate in German? Yeah?
I mean, übersetzt Wort für Wort heißt Abgeordneter, aber man kann es übersetzen mit für einen Bereich zuständig.
Yes and no. It's difficult to remember like that. Delegate, to delegate, the verb delegate. What does that mean? German? Delegieren. What is delegieren? To delegate. Wendet ihr?
Ja, wenn man wen was anschaut. Also wenn wir in eine gewisse Richtung halt.
Aha. Yeah, it's very hard. Delegate means that I ask somebody to do something instead of me doing it on my own. So I could say, I delegate to you to clean the desk, the blackboard every time I come in. That could be a delegation. So I ask you, I don't have time, or I can't, or I don't want. So I ask you to do it instead of me. I delegate this task to you. And this is exactly how you can remember a delegate. A delegate is something, let's call it a pointer to a function, but it's not only a pointer, it's something which you can ask to call a specific function on your behalf. You're not calling it directly, but you're just asking something, the delegate, to do it instead of you. Understand what I mean? So a delegate in C# is really a thing. If you create a delegate, if you pass a function, if you pass a delegate to a function, you're really passing a thing to that function. There is something in memory, the so-called delegate. This is something. These are bytes in memory, and they are just representing the function you are calling. You are delegating the function call to the delegate. Understand what I mean? Delegieren. I think you know that from other classes here, what delegieren means. It's very important in business life, and it's the same here in C#. Understand what I mean? Good? Nice. Okay, good. Let me quickly create a console app here. You don't need to follow along. It's very basic at the beginning. Just follow in your mind. We will just recap one or two things where we didn't have the time to go into details in our last lesson. When it comes to the next lesson, we do a short break afterwards, as I told you. Then it makes sense that you follow along. But this sample is so trivial. Yeah, it's not worthwhile following along. So let's create a new console app here. I updated my Visual Studio yesterday, so we have the latest and greatest Visual Studio here. Let's immediately switch to Net 5 in order to switch the target framework to .NET 5. And with that, we can get rid of all this main and so on stuff. You can remember? Can anybody remember what the name of this feature is? Writing a program without main? Yeah?
Top-level statement.
Exactly, top-level statements. I like that. Okay, let's do a short quiz. Can anybody describe me in his own words what this application does? Line by line. First line using, okay, we don't have to talk about that. Second line, what is the second line? What's the word action? What does it mean here? We discussed it briefly, but not in details last time. Yep?
Action is a function without a return value.
Action is a delegate without a return value. Does it have parameters?
It can.
It can, but in this case?
It doesn't.
It doesn't, exactly. So A is a delegate referring to a function without parameters returning void, as you can see it here. So if I run this guy here, should execute pretty quickly, it says hi. That's fine. Correct. If we take a look at action here, then you will see it's a delegate returning void, getting no parameters. Good. Next one. What is action of int? A delegate?
Delegate with a parameter which type is integer.
Return type?
Void.
Exactly. Why? Because actions are always return type void. Exactly. So A2 is referring to, please give me another few minutes and we'll do the break in a second, okay? A2 is referring to a function which gets one parameter of type, if I hover over it you can see it, integer, and we can call it by passing in an integer. Exactly. And we can go on and on and on with this stuff. We could say string and string, A3 equals to string 1, string 2, goes to console write line S1 plus S2. Something like this. I don't think that I have to describe what this thing does. Foo bar. A3 is a delegate getting two parameters of type string. Therefore, here S1, this one, is a string because the first parameter is of type string. S2 is of type string because the second type parameter to action is of type string. Is that clear? Difficult? No. How many of these type parameters are there? Can you remember? Did we tell about that? Did I tell you that? Yeah?
18.
No, 16. I think I told you 18 last time, but I looked it up. It's 16. Yeah. How could you find it out? Any idea? Pretty simple. Just go to source.net, type in action. It will show you the delegate action. And here you see the source code, as you can see it here, the source code directly from the .NET Core library. And if I scroll to the right, you will see here the highest value is 16. This is code that Microsoft wrote. Okay? Good. Last thing, and then we are done with the repetition and we'll do new things. If I delete all this stuff and I do the same thing with funcs. Func of int f. This is strange, isn't it? What is func? Yeah?
Func is a delegate that uses the first parameter as a return value.
Func is a delegate. In this case, f. Func is a delegate that returns which type? The last. Okay, so in this case we only have one. So the first one is the last one. So exactly, no parameters, and int must be the return value. If I try to return a string, I get an error because the string is not compatible with int. Understand what I mean? Now, let's make it like that. F2 is a delegate that gets which parameter? The first one, integer. This first integer refers to the first parameter. The last, as you correctly said, the last type always refers to the return type. So in contrast to action, where we always return void, function always returns the last type parameter. So a func of int bool would be what? A function that gets how many parameters? 2. Which type? Int, and the return type is Boolean. So I could write something like n1, n2, n1, n2. n1 is integer, correct. n2 is integer, correct. And the equal sign has as a result Boolean. So this is a function indicating whether n1 and n2 are equal. Understand what I mean? Awesome. And if we take a look at the code, we will see that it's really nothing special. Let's go to source.net again. Let's look for func. Where is the delegate func? T. No. Come on. System link method. Can I find? Here is the delegate func. No. Private read-only func. I can find it, but somewhere it really exists. I can find. We can take a look like that. Let's take a look like that. Exactly. Here you see it. Delegate, result, and the result is the last parameter. See that one? Is that clear? Do you understand what action and function is? It's just a way that you don't have to declare so many custom delegates. Okay, this is a pre-baked delegate that you can just use. Good? That was a quick repetition, and with that I would say let's make 5 minutes break. It's 5 minutes before 9, so we'll see each other at 9 again, and then we'll do something new. Okay? See you in a few minutes. Okay. Good. Welcome back to second lesson of today's course. Today we want to primarily talk about the type system in C#, but before we do that, we have to discuss at least a little bit a concept in C#, which is related to delegates, or higher order function it's called. And I'm not sure whether you are fully familiar with it, but it's crucial for your understanding for modern software development. This concept that we will discuss in the next half an hour or so, let's see how fast we progress, is not just relevant for C#. It's applicable equally in any major programming language that you nowadays find in the practical software development world. So it works exactly the same in JavaScript, it works exactly the same in TypeScript, it works exactly the same in Go, in Rust, in C++. They all have the same concept. Of course, all of these languages have a little bit different features, but overall it's always the same. And the concept that we are going to talk about is called closures. I need to find out what you already know. Do you know what closures are?
No.
Have you ever heard about that?
No.
You never have?
No.
Okay, then it's good. Then we have something new. It's really something fundamental. Before we go into the details about closures, again, I need to find out what you already know. Do you know what the difference is between stack and heap? Yes? So what is stack? What do I mean when I say a certain variable lives on the stack? What does that mean? Can we write an example? Of course we can write an example. Int calculate something. Let's create a variable. It doesn't matter. Closures. If you want to create a closures, okay? Let's do it like that. So. We'll not write a lot of code. Question? Ah, awesome, awesome. Okay. Yep. So, question. Factor. What is the type of factor? Data type. Yes? Int, correct. Does factor live on the stack or on the heap? Yeah? Correctly. Why?
Because it's a value type and the value is stored on the stack.
The value is stored on the stack. I like that. N. Type int. You of course can read it here. N lives on the stack or on the heap. Parameters are passed into functions over the stack or over the heap.
Depends.
Really? On what?
Not with int, but with other.
Ah, I see. We'll cover that a little bit later on. But with int,
It's a value type, so
it's a value type, so
it's stored on the stack.
stack. I like that. And the return value goes over the stack or over the heap? Stack. Return values always go over the stack. Okay, exactly. So can I, somewhere out here, do something like this? Of course not. Why? Why isn't that possible? Yeah?
Because the constant vector is not in the same scope.
It's not in the same scope, and additionally, factor is only living on the stack of calculate something. So absolutely nobody can access this function, this variable here, because out there it doesn't even exist. Do you really understand what the stack is? Stack means that when you enter the function, variables are put on the stack, and as soon as you leave this function, as the function is completed, the variables are removed from the stack. Understand what I mean? Good. I write some code. This is obviously now a function which is recursive. The function calls itself and calculates something. It doesn't matter what you do. It's just a recursive function. You know what recursive functions are, right? A function that calls itself. Okay, what does it mean for the variable factor? If we call the function calculate something, and then calculate something calls itself again, and again, and again, and again, by passing always n minus 1. So we start maybe with 3. Then we call the function again with 2. Then we call the function again with 1. And then we call the function again with 0. And then we are done. What about factor? Do we have a single factor? Yeah?
We have a single factor because the calculate something method is not, doesn't end before the new calculate something is open.
Your train of thoughts is correct, but we don't have a single factor. How does the stack work? Stack is a Stapel in German. The idea that you have to keep in mind, and if you are not completely aware of that, please listen closely. Stack means that with every call of the function, you get new variables on the stack. So the first time you call calculate something, factor is put on the stack. And when you call the function again, recursively, you get a new factor on top of it, or the stack typically is drawn towards the earth and not upwards, so downwards and upwards. So we have the first factor, calling it recursively, we get a second factor. a second instance of the factor variable, next call recursively, next factor, next factor. So we have one collection of variables over the other. And when the lowermost instance of calculate something is done, the first factor is removed from the stack. And we are back to the secondmost factor of the stack. So the stack is growing, 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 growing with each recursion. And we are going back, 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 once we return from all these functions. Understand what I mean? This is how the stack works. I am sure you covered that in previous years, but yeah, if you're not so long into software development, it's sometimes important to recap what stack really means. Okay? Keep that in mind. You will get a homework today. We will work on it today in our exercise lesson, but you can finish it at home, where this might prove valuable. Okay? But we'll talk about that later. So you understood where factor lives, what calculate something does. That's fine. Good. But now we are building something that is really strange. We will build a so-called higher order function. A higher order function is a function that doesn't return a simple data type, but a function that returns a function, or that gets a function as a parameter. Let me show you what I mean. I can keep this one in here and just collapse it, and this time we're doing something like this. We say, we return, please note this is the return type, func of int and int. Create calculator var factor equals 42, return n goes to n multiplied by factor. And to understand that fully, we will say up here func int and int calculator equals to create calculator, console write line calculator 2. So I will let you type that in, and then we will discuss these few lines of code. Line 8 is no longer relevant. Just line 16 to 20 and lines 5 and 6 are now relevant. This is not so easy to understand. By the way, this is a so-called pattern. It's the so-called factory pattern. So we are creating a factory for functions. Good. Let's analyze what we have written here. The idea is that we write a function, create calculator, which returns a function. To be more specific, it returns a delegate. Understand what I mean? So I'm not getting back a result, but I'm getting back a function which I can use to get a result. Let me describe it in everyday terms that I'm sure everybody understands. I can ask you to bake a Google hoop for me. So I will call bake Google hoop, and the result will be a really delicious sweet, a Google hoop. That is a regular function. His return type is Google hoop. Understand what I mean? But now I'm creating a higher order function. I'm saying create a recipe for a Google hoop. I will not get a Google hoop, but I will get a recipe from you, which I can later use to not just create a single Google hoop, but a lot of Google hoops. Understand what I mean? This is a higher order function. So we are creating not a result of a calculation like we did in line 8, but this time I'm asking to create a calculator. I want to get back a delegate, which I can call over and over and over again to do a specific calculation. Understand what I mean? Maybe you can remember this Google Hoop thing, because it always helps me to understand the difference between a concrete return type and a factory pattern. In computer science, we don't say it's a Google Hoop pattern, but it's a factory pattern. But yeah, maybe you can remember it. Now, in our case, our recipe gets a single integer as a parameter and returns a converted integer. So we give in a number and we get in a calculated number. Understand what I mean? Good. This would be pretty simple if we just write something like this. This is trivial. Now we don't have to talk about it because it's just a delegate, just multiplying something by 2. That's not a problem. But here we have a very specific problem. Take a look at this function here. This here, when in our code will we call this function? We will call this function here not within create calculator, but we call this function outside. You see it? This is where the call happens, because this function is returned, oops, sorry. This function is returned here and is called here. Understand what I mean? Now, inside of this function here, we are using factor, and now we have a problem. Factor lives where? On the stack. Previously we learned that it lives on the stack, but you're right. It cannot live on the stack. Because if it would live on the stack here, how long would it live? Until create calculator is done. But now we have a problem because we are going to call the resulting calculator much later, at a point in time when there is no factor anymore, because the stack is gone. Understand what I mean? That's a problem, right? And how does C# and all the other programming languages solve that? You said it. They are promoting the factor from the stack to the heap. Oh my God, what does that mean? What does promoting from the stack to the heap mean? What they essentially do is they are recognizing that you are using, inside of your function here, that you are using a variable which is outside of the scope of this delegate here. The factor is not a local variable to this function here, like n. N is the input parameter. But it's outside. So on the one hand side, we have a delegate to a function. And on the other hand, we have a local variable. But their lifetime differs. Factor has a shorter life than the function that we return. Understand what I mean? So later on, when we call the function, factor doesn't exist anymore, we have a problem. And this, exactly this, is what people call a closure. It's technically not 100% correct what I say now, but what I tell you now, but it helps me a lot understanding closures. Closure means that you have a local variable, factor, that you have a function. In this case, there's this function which multiplies n by a factor, and they are friends. They are close to each other. Closure. Understand what I mean? I hug you, factor, I love you, you are part of me. Understand what I mean? The technically correct term is called, the lambda method here captures factor. Fangen, okay? So it's not just hugging and saying you are part of me, but I'm capturing you. You now belong to me. And what C# in reality does is they are binding the lifetime of factor to this method. And what they essentially do behind the scenes, let me show you what they do behind the scenes. Behind the scenes, they are rewriting this method. They are creating a class, best friends. Of course, it is not called best friends in reality, but I think you can remember it. What is best friends? Best friends is our public int factor, something like this, and our calculator. You see, because our method here is capturing the factor, what this C# does is it says, okay, you are so close to each other, you love each other, I do not want to separate you. I put you together in a class so that whenever the function exists, the factor also exists. You cannot rip the class into parts. It's not possible. They belong together. They are close to each other. They are a closure. Understand what I mean? Yeah? And what they then do with the create calculator is they create something like best friends, create calculator internal, and what they do is they say return new best friends with factor equals to 42. Understand what I mean? Look at the difference. I'll scroll out a little bit. By the way, I can check in this live coding again if you want. Last time I checked it in, you asked me to do that, so I did it. And I can check in that code again so that you have this code and you can remember what we talked about. Additionally, you have the video. I think that should be fine. So look at here. This here is a local variable. It lives on the stack. Here, you are capturing this local variable, and you can just return a function. In reality, C# creates a class because it recognizes that this thing and this thing, they belong together. And in reality, they are creating an instance of this auto-generated class. And what is a class? A value type or a reference type?
Reference type.
And where does a reference type live? You said it, on the heap. And this is meant with the value from the stack is promoted to the heap. Because factor is no longer a variable on the stack, but factor is now a member of a class and created on the heap and not on the stack. Question?
So when you create the calculator,
Yes.
it saves the function on the heap. No?
Well, not really, because the function becomes a member in a class. It's just a regular class. The good news is that you do not have to care about these details so much. The only thing that you have to keep in mind when programming C# is that here you have a capturing going on. So when you are a professional C# developer, sometimes it really matters if something lives on the stack or if something lives on the heap. For instance, with multi-threaded programming. You know what multi-threaded programming means? Multiple threads run at the same time. Variables on the stack are always thread safe. They must be thread safe. Variables on the heap are not. Therefore, sometimes it's really important to understand, do we have something on the stack or do we have something on the heap? But if you don't do multi-threaded programming and in 9 of 10 cases you don't care about it, you can simply forget about the details. Still, you have to understand what a closure is. You have to understand the problematic. And the only thing that I want you to remember is that, when we have a closure that captures variables locally, behind the scene, a class is generated. Understand what I mean? So if a lower class student asks you, what is a closure? You can say, imagine a higher order function. Something like this. Can you remember what a higher order function is? Google Hoop? A function that returns a function. Yeah? If you have something like this, and this return function uses a local state, a state on the stack, in our case factor. these two things are brought together, yeah, in a separate class, and the local variable gets promoted to the heap. I know this might sound a little bit complicated now, but you don't have to understand the details. However, some of you would maybe like to know the details. Which tool would you want to use if you really want to understand whether C# really generates such a class and how it looks like? Last time we used it, yeah? .NET Spy. Let's take a look at it, shouldn't we? You don't need to follow along. Just look at what I do. That's perfectly fine. So I start the dnSpy. Starting dnSpy takes a few moments on my computer, so please bear with me. dnSpy loads a lot of stuff from the local disk. So here we are. Let me open this guy here. Bin debug net5, and we'll take the DLL. Here it is. I will zoom in immediately when I've found it. Yep. Okay. See that one? That is the generated class. And it consists of our factor, see that one? And it consists of a function. The names are pretty strange. The name of the class that C# generates is lower greater C underscore display class 0 underscore 0. That's the name of the class. It's exactly the same what we did with best friends. But yeah, it's an auto-generated, it's a robot-generated class name. The name of the variable remains factor, but the generated function, it doesn't have a name. We ask the C# compiler to generate the name. And the name, again, is very, very strange. Lower main greater greater b underscore underscore 3. That's the name of the function. And we can even take a look at the function. If we take a look at the code, you see it contains a multiplication. Okay. And it multiplies by the factor. See it here? And the factor comes from the display class. So with dnSpy, that's the point that I want to make here. With dnSpy, it's pretty easy to take a look behind the scenes, to lift the curtain, and to see what C# really does. Okay? Good. Difficult, isn't it? Again, good news is this is what I call Harry Potter programming. A little bit of fairy dust and it just works. So if you want to stay with the, let's say, blue pill, then forget all about this stuff down here. Just use it. C# will do its magic and it just works. And in 9 out of 10 cases, you simply don't care. But this one case, when you have this one case where it really matters, I hope that you will remember what I told you now. And you will remember, oh, promotion to the heap, generated class, and then you will probably be able to find out the details by just Googling for closures or taking a look at the generated code with dnSpy. Questions? I need to understand a little bit where you are. Show of hands, and this will not be graded. I ask you to really be honest, okay? Who thinks, okay, I got that. I understood it. Okay, who thinks, I mostly understood it. I have an idea. Maybe not all the details, but I got it more or less. Anybody who is completely lost and says, I have no idea what this guy is talking about. C what? C#? Never heard of that. No. No. Is anybody completely lost and has no idea what we are talking about? Okay. If you are, re-watch the video. Maybe you are shy and you are not brave enough to show your hand here. So re-watch the video. Try to read a bit about it if you really need it and if you want to know it. And if you still can't understand it, send me an email or ask me next time when we see each other, okay? Good. So this is higher order functions and closures. As I told you, the same is true, the same exists for C++, Go, Rust, JavaScript. JavaScript is so much relying on the fact that closures exist. JavaScript, they use closures in nearly every line of code. It's a little bit over dramatic, but in every program you find it over and over and over again. JavaScript has been built on the concept of higher order functions and closures. So if you want to become a good JavaScript developer, you definitely have to understand how closures work. Good. Nice. I will save this example. Let me quickly rename this. This is the closures example. So I will check it in later so that you have the source code again. Good. Close it. Start a new project. Breathe in, breathe out. New topic.